This video looks at binomial expansion and Pascal's triangle. Our QCAA subject matter is to recognise and use the link between Pascal's triangle and the notation NR. That there is equal to NCR, it's just a different way of seeing it, and to expand x plus y to the n for small positive integers n. Now Pascal's triangle, this is probably going to look scary, but it's not that bad. Pascal's triangle is basically you write your numbers, so 1, 1, 1, and then the next one is add those two ones to get the 2, 1. Then we start with 1 again, 2 plus 1 is 3, 2 plus 1 is 3, then finish with a 1. Start with 1, 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then you finish with a 1. So that's how we get the Pascal's triangle. So if you see my diagram here, what I'm trying to show is that 6 plus 4 gives me the 10, okay? It's also symmetrical, so you can see these two 5s are here, these two 10s, and we always start and finish with 1s. And they relate to our NCR, as you can see in my other triangle. So row 0, you've got 0C0. Row 1, 1C0, 1C1. Okay? So using Pascal's identity, looking at this triangle that I have here in blue, okay, if we look at the corresponding elements for that, so that's here, that's telling me that 4C2 plus 4C3 has to equal 5C3. Okay? Because the 2 above equals the 1 below. And that's all that Pascal's identity is showing you, that n minus 1 CR minus 1 plus n minus 1 CR has to equal NCR. Now our binomial theorem of expansion also uses our NCR. Now refer to your formula sheet, these are on there, and also don't freak out, we can simplify this to make it easier. So let's look at an example, expanding 2 plus x to the 4. Now we have to the power of 4, so we need to get down to the 4s on our Pascal's triangle. So we're going to use this row. Okay, so write those out, they will be our coefficients. You then look at your first thing, which is the 2. And you put that all the way along. Then start at your highest power, 4, 3, 2, 1, 0. Then move along to your x. Put it all the way down. And go in the reverse order for your powers, 0, 1, 2, 3, 4, and then put your plus signs in between. Okay, so what we have now is 1 times 2 to the 4. 2 to the power of 4 is 16, and x to the power of 0 is 1. So that's 16, plus 4 times 2 cubed. 2 cubed is 8. 4 8s are 32, x. Plus 6 times 2 squared. 2 squared is 4. 6 times 4 is 24, x squared. Plus 4 times 2 is 8, x cubed. Plus 2 to the 0 is 1, so we've just got the x4 at the end, and that is now expanded. One that's a little bit more complicated, we're still doing to the power of 4, so we still have those same coefficients. So 1, 4, 6, 4, 1. So we've got 2, so times by 2 all the way along. Start at your highest power and go down. Then move to your next thing, which is the minus 3x squared. So you got minus 3x squared. Okay, start with your lowest power and go up. And put your pluses in the middle. Now I recommend doing an extra step in this one. 2 to the power of 4 is 16. That's all times by 1. Plus 4 times by 2 to the power of 3 is 8. Negative 3x squared. So we've got minus 3x squared because that's all to the power of 1. plus, we've got 6 times 4 is 24, times by negative 3 squared is 9x, 2 times 2 is 4. Plus 4 times 2 is 8, times negative 3 cubed is negative 27x, 2 times 3 for our powers is 6. Plus negative 3 to the power of 4 is 81, so you've got 81x, 2 times 4 is 8. So remembering, we're just multiplying those powers from our index laws. So neaten that up, 16 times 1 is 16. We have 4 times 8 times negative 3. So this is going to be a minus here. So you got 4 times 8 times 3 is 96x squared. Then we're going to have a plus because there's no negatives here. 24 times 9 is 216 and our power is x to the 4. Then we have, it's going to be a minus now, 8 times 27 is minus 216, x to the 6, and then we have plus 81x to the 8. And that is done. Okay, much easier way of doing it than using the formula. Now let's look at the general term in a binomial expansion, and this is probably going to freak you out. So this is to find just one term. So in the previous examples, we expanded it out in full. This is only if we want to find one term, and you have to remember that you can just go back and expand it out in full if you want to. You don't have to just find a single term. So you don't have to learn this. You can just expand it and find the term that way. So read through what I've got here, but what is most important is what's in the green. That tells us how to find our term. So for the question here, it says, for the expansion x minus 3y squared all to the power of 6. And I want to find the term and the coefficient of x cubed y to the 6. So number 1, if we look, we've got to the power of 6. So that means my n equals 6. Okay? I also want x cubed y to the 6. So if we look at that 3 has to be our n minus r. So n minus r equals 3. We know that 6 is n, so 6 minus r is 3. So that means my r has to be 3. So I've got n is 6 and I've got r is 3. So that means now that I have my term is going to be equal to, I don't like writing it with brackets, so it's going to be 6c3, and then we're going to have a here is our x, so x to the n minus r, 6 minus 3, and then our y term is the negative 3y squared, and that's all going to be to the power of 3. Okay, so now we've got 6c3 x cubed, negative 3 cubed is going to be negative 27, y 2 times 3 is 6. To work out the 6c3, go to your calculator and you get 20. So that's 20 times x to the 3 times negative 27 y 6. 20 times 27 is 540, so I've got negative 540 x cubed y to the 6. Okay, so it said determine the general term. So the general term is negative 540 x cubed y to the 6, and the coefficient is negative 540. Okay, but I stress to you, you can expand these out like we did in the previous examples, and you don't need to learn this process. So exercise 11E, page 411.